So from B to A, see here, one thing that you should have to observe one point here. So that is specifically telling here, it is the here it is when it is following the path, when it is following the path B to A, what is the final one? So this is the final. Always it is the final state minus the initial state, right? So it is always final state minus initial state. And then WB to A. So here it is nothing but minus plus, right? Then work done, that is work done onto the system it is. So here it is now work done. System is written from the work done on the system. So the work done on the system it is minus 10 point, sorry, it is 21. It is 21 minus 21. So you will get it as minus 73 kilojoules. You will get it as minus 73 kilojoules. So here minus means the system is liberating the heat, or heat is rejected by the system. So here heat rejection is taking place. Heat rejection is happening from the system because it is minus 73. So that is the heat is rejected, right? Hope you understood. So that is the second bit solving. Then how you can solve for the third case? The third case is the internal energy at the state A is mentioned, and the internal energy at the state point B is also mentioned. So how you are going to solve that particular case? So the C bit, right? So the C bit, that is ADB. So that is what you have to observe. So that is WADB. WADB. So that is nothing but equal to, first initially it is the WAD plus WDB, work done in this particular, because if UD, find the heat absorbed in the process. See, find the heat absorbed in the process AD, and DB separately it is mentioned. So separately it is mentioned. That means WAD. What is the WAD? That WAD, the WAD, you can find out, that is, I think it is from ADB it is given. So the system does here from ADB, right? So that is from this case, because when you observe clearly, this is nothing but the dB. It is the WBD. It is 0, right? So that is nothing but equal to WAD. WAD. So here you will get this particular thing as 10.5. You will get it as 10.5 kilojoules. 10.5 kilojoules. So WAD is equal to 10.5 kilojoules. So in the same way, that is the Q is the Q of AD. That is Q of AD is nothing but equal to UD final state minus initial state plus WAD. What is the UD? It is 42 minus 0 plus WAD. WAD is nothing but 10.5. So it is 10.5. 42 plus 10.5. So you will get that one as around 52.5 kilojoules. 52.5 kilojoules, right? But we know that QAD. So that is QAD that is equal to QAD plus QDB. QAD plus QDB. What is the QAD? That is QAD, it is given as, so it is QAD is 52, and you have to find heat absorbed in the process AD and dB. So it is this is the 52.5 heat is entering into the system. Then QADB. What is the QADB? That QADB value is QADB value is 62.5 is equal to 52 plus QDB. QDB. So with this case, QDB, you will get that it as 10 kilojoules. 62.5 minus 52.5. So you will get it as 10 kilojoules. You will get it as 10 kilojoules. So this is how you need to solve the problem for this particular site. So this is the second, and these things, how the path is going to be moving, what is the initial state and what is the final state. So this is how you have to solve the numerical problems connected to this site. So this is the second problem in this site. So when you are going to apply the, because what is meant by intensive property and what is meant by extensive property, you should have good clarity onto the property, intensive property and extensive property, where which one is the final state, which one is the initial state, whether the process is a compression process or it is a expansion process. So that everyone has to understand this particular. So the third problem is that a piston and cylinder device, right? So piston and cylinder device, a piston and cylinder machine contains a fluid system which passes through the complete cycle of 4 processes. So cycle is nothing but it is consisting of the various process. Cycle is nothing but consisting of the various process. So in this case, during a cycle, the sum of all heat transfers is minus 170 kilojoules. The system completes the 100 cycles per minute. System is going to complete 100 cycles per minute. Then complete the following table. So here, whatever the empties are there, complete the following table showing the method for each item and compute the net rate of work output in kilowatts. So this is also the empty cells are there. So this is how you have to solve the case. So now here, and observe the empty cells, and based on that particular site, then you have to write the answer. So first thing is apply the first law of a thermodynamics. Apply the first law of a, say suppose if you take in each and every case, now you have to apply the process. So the process A to B, right? So in the process A to B, then apply the first law of a thermodynamics. Q is equal to, then here it is mentioned as a delta E. That's why I will use the same thing, that is delta E plus W. Delta E plus W. Then in this process, what is given? So it is given as 0 is equal to delta E. So it is also nothing but equal to delta E, right? That I have to find 0 is equal to, that is delta E. Here the value is given, 0 is given, so that's why 0 is taken. Delta E it is not mentioned, and W is nothing but, so it is 2170. So from this case, the cell that is delta E, you will get as a minus 2170 kilojoule per minute. So that means that this particular cell is filled up. That is here, the value is minus 2170 kilojoule per minute. 2170 kilojoule per minute. So in the same way, go for the process B to C. So here also B to C. Apply Q B to C is equal to, that is delta E plus W B to C. Then Q B to C, what is the value? 2000, 21,000 it is given. is equal to delta E, here also it is not given, plus B to C, here the value is 0. So therefore, here the delta E, that is nothing but equal to minus 21,000 kilojoule per minute. So here this cell is also minus 21,000 kilojoule per minute, minus 27,000 kilojoule per minute. And the third one, that is C. So here the process CD. So here also QCD, that is equal to delta E plus W C to D. So what is QC to D? Here it is given as 2100 is equal to delta E is minus 36,600 plus W C to D. So you will get the W C to D. So that W C to D you will get as a 34,000. The answer is 34,500 kilojoule per minute. Kilojoule per minute. So here the answer is 34,500 kilojoule per minute. Kilojoule per minute. So that is over. Next one is process D to A. Process D to A. So process Q D to A is equal to, that is the delta E plus W D to A, right? So that is here Q D to A, it is what you have to find, and here it is Q, that is Q D to A, it is not given, and here also it is not given. Delta E is also not given. So all these cells are empty. So all these cells are empty means, then how you are going to treat that thing? So in this particular task, then already according to the first law of thermodynamics, what is going to indicate? So the cyclic integral of a heat transfer is nothing but equal to the cyclic integral of a work transfer. That is sigma Q is nothing but equal to sigma W. Sigma Q is nothing but equal to sigma W. So connected to that particular task, right? So that is the sigma of a cycle is given. See, observe. What is this one? This one. For the sum of all the heat transfers is sigma Q is equal to minus 170 kilojoule. Minus 170 kilojoule, right? So, and here the system is going to complete. The system completes 100 cycles per minute. So that you should not forget, right? So in this this is sigma Q. When I write this sigma Q, that is Q A to B plus Q B to C plus Q C to D plus Q D to A is equal to minus 170, and this cycle is going to be completed with 100 cycles. So that is the 100, and it is in kilojoule per minute. It is in kilojoule per minute, right? So QAB, here it is 0, then QB to C. QB to C, what you have got? It is 21,000, right? Next, QC to D. Here the answer is minus 2,000, already it is covered, plus Q D to A is equal to minus 17,000. So with this case, then Q D to A, you will get it as Q D to A is minus 35,900 kilojoule per minute. Kilojoule per minute. Now I think Q D to A you have got. So once after getting this Q D to A, this Q D to A, then the cyclic integral of this dE is also equal to 0. The cyclic integral of any property is also equal to 0. So already we have covered that. the cyclic integral of dv is equal to 0, the cyclic integral of du is equal to 0, the cyclic integral of dp is equal to 0, dh is equal to 0. So connected to that one, that is delta E, delta E, delta E A to B process plus delta E B to C plus delta E C to D plus delta E D to A, and that is nothing but equal to 0. So when you substitute all these things here, that is the delta EA, delta EB, then find with this case, then delta E D to A you are going to get. That delta E D to A, the answer is minus 17,700, minus 17,770, 17,770 kilojoule per minute, kilojoule per minute, right? So 17,700. So that means now you have got this value also. So once after getting this value, then already we know that that is Q is equal to, that is Q D to A. Q D to A is equal to E A to D plus, that is the delta E A to D plus W D to A, right? W D to A. So we know that because now we have to find out this particular work. So this is what you need to find. Already Q D to A. So that is the Q D to A is this one, minus 35,000. So here the things, that is minus 35,900 and minus that is Q, that is what it is there. And another thing is delta D to A, that is minus 17,770, 17,770. So you will get the answer as minus 53, minus 53,670 kilojoule per minute. So this is how you can make the calculation of the work, kilojoule per minute. So this is the kilojoule per minute. So you should, the student should be more careful about this revolutions per minute, 170 into 100 revolutions per minute. And when you are going to write this one, so according to the first law of thermodynamics, students should not forget about this the cyclic integral of heat transfer is nothing but equal to the cyclic integral of work transfer, or it is sigma q is nothing but equal to sigma w, right? So while establishing this particular relation, then you are going to fill all these particular relations. You are going to get all these particular cells are going to be filled up. So this is how the student has to solve this particular type of a problem from this side. Hope this particular things are clear.